Ladies and gentlemen, welcome to Hong Kong IE Civil Division event, technical webinar on conserving biodiversity through eco-friendly infrastructure design and operation, organized by the Hong Kong IE Civil Division and the PolyU. I'm the MC of today. We are honored to have Dr. Professor Yuhong Wang from the Polytechnic University and the Department of Civil and Environmental Engineering. Professor Wang received his academic and professional trainings in both construction management and road pavement engineering. He is a fellow of the Hong Kong IE and a registered professional engineer in the US. Currently, Professor Wang's main research and interests are future urban green and intelligent infrastructures, aiming to make our cities cleaner, smarter, more resilient, and more environmental friendly. Without further ado, I would like to invite Professor Wang to deliver the talk. Professor Wang, please.
Okay, thank you, Fiona. Firstly, I would like to thank Hong Kong IE Civil Division for inviting me to present our research. And the title of my presentation is Conserving Biodiversity through Eco-Friendly Infrastructure Design and Operation. So this is a topic we normally do not care a lot or get involved a lot as civil engineers, but we think it's quite an important topic. Thank you very much, ladies and gentlemen, for spending your valuable time with me on this presentation. Here's the outline of my presentation. First, I'm going to give a brief introduction. Secondly, I'm going to talk about the backgrounds of our study. Let's start with introduction. Well, like before playing a movie, we got to play some advertisement. So I was asked by our department to offering some advertisements about our department. So I work for the Department of Civil and Environmental Engineering at PolyU. This is the 50th year of our department. We are, I see someone raise a hand. Can you hear me clearly? Is there any technical difficulty? Okay. If there is no problem, I will continue. Okay, I assume you can still hear me. So we have lots of achievements as a department. For example, we have lots of scholars ranked world's top 2 scientists, and here are some ranking. And in recent years, we also received some large grants from a very competitive funding scheme. Here are some examples. One group is called a theme-based research scheme. We also receive a Green Tech Fund and a Lantau Conservation Fund, and also RGC Research Impact Fund, etc. And here are the programs offered by our department. We have an undergraduate program and also taught graduate programs. One is in Master of Science in Civil Engineering. Another one is Master of Science in Environmental Management and Engineering. We also have some research postgraduate programs. And here are our outstanding alumni. We are very proud of our alumni who have made great achievements in the civil engineering field. And here are our facilities. We have 30 laboratories, 2 workshops, and 1 research center in Shenzhen. So we can pretty much do nearly almost everything, everything related to civil engineering. If you want to learn more about our department, please visit our website and pay attention to our newsletter and social media panels. Now I'm going to move to this presentation, okay? Let's start with backgrounds. Well, biodiversity loss. As civil engineers, we have heard a lot about climate change, how to adapt to climate change in civil engineering design. However, another very urgent issue is biodiversity loss. Recent decades witness an alarming rate of loss in biodiversity around the world. And there's a famous book written by Dr. Elizabeth Colbert. He used a term called the sixth extinction. Well, before our human era, there were already 5 mass extinctions. All those extinctions were caused by some disasters. Now we are currently in a 6th extinction. We are seeing a rapid loss in biodiversity. For example, 1 million out of 8 million of the total estimated number of species on Earth are in the brink of extinction. And this extinction is mainly attributed to human-related activities, such as climate change and land use change. We as a civil engineer, we like to modify the land. So we are actually heavily related to this mass biodiversity extinction. Land use change, such as infrastructure development, is believed to be one of the major causes of biodiversity loss. So why do we care about it? Well, of course, firstly, if you are you believe in Buddhism philosophy, there's a moral obligation to protect life, to conserve life. Well, if not, if we are from a selfish perspective, point of view, biodiversity provides lots of service to human. So firstly, this biodiversity gives us an indicator of our living environment. If many other species, they find it's not suitable to survive anymore, that provides some indication of the environment we are currently living in. Secondly, biodiversity provides rich ecological services. So here are 4 groups of ecosystem services according to Millennium Ecosystem Assessment. These services include supporting, provisioning, regulating, and culture. And on the right-hand side are constituents of well-beings. So these connections, these arrows show how the ecosystem services affect the well-being of human beings. Let's use some simple example. For example, pollinators assist with 80% of world's flowering plants in reproduction. Well, of course, we live in Hong Kong. We can easily buy all the food from a grocery store, supermarket. But where we get the food? Well, we get lots of food because of these pollinators. Without these pollinators, such as bees and butterflies, humans would lose much food and beauty from the nature. However, according to recent studies, this study occurred in US. I did not find any similar study locally, It's reported that more than 700 North American bee species are declining at a dangerous rate due to habitat loss and pesticide use. Let's see another example that's quite close to Hong Kong. In Hong Kong, we have an interesting animal, sea animal called horseshoe crab. It's lived in the ocean, in the coastal area in Hong Kong. For example, in the coastal area of a northern metropolis. So this picture, the top left, show a photo of a horseshoe crab. And this horseshoe crab is very important. We may not pay much attention to it, but horseshoe crab helped to keep most of us alive because vaccine, most of the vaccine, like a COVID vaccine, is tested for safety using horseshoe crab blood. It has a unique blood, the blue color. Well, we may never, in our ordinary engineering practice, we may never thought about, well, this horseshoe crab is actually closely connected to our house and our land development, very likely interrupt or even destroy their habitat. Another example, we talk a lot about how to combat climate change, how to reduce or even curb the growth of carbon dioxide level in our climate. Or trees and other vegetation, they can absorb lots of carbon dioxide, not only through biomass, but also through the underground fungi population. One group of fungi is called mycorrhizal fungi. They account for, well, when fungi and tree roots form very strong symbiosis. Tree roots provide fungi food, while fungi help tree roots get nutrients and water. So the carbohydrates, about a third, about 3 to 13%, but up to 50% of the plants, the carbon generated by the plants, go to the fungi. So it's a recent study found about these mycorrhizal fungi. Okay, every year, about a third of the emission, it can absorb about a third of the emission produced by world fossil fuel. In other words, so this fungi can help sink this carbon dioxide to the ground. Of course, this study did not report the effluent of the carbon dioxide. If we consider the effluent or decomposition of this carbon of these components, the carbon sequestration rate will be less. But anyway, so plants and the fungi, they play critical role in carbon sequestration. Now let's talk about the urban trees, because we will talk about the biodiversity in cities such as Hong Kong. We can immediately think about the trees and the plants. Trees offer numerous benefits to urban residents, especially amid the global climate change. So recently we did a study, try to understand the benefits of a tree to city. So I summarized some of the points. So the benefits range from urban cooling, flood mitigation, to enhancing people's mental health and physical health. For example, some very famous paper, well-known paper published in Nature journal series talk about the benefits of the tree. One of the benefits I was quite impressed is about mental health enhancement. They found some connections. In this, there was a study in Germany. They found out, well, in the city district, if there are lots of trees, lots of green spaces, people tend to have less mental problems. While in urban districts, there are no tree or even little plant, there are lots of mental problems. So they found some very interesting correlation between the mental health and the number of the trees. And also, let's use two examples. So another example of trees benefits is urban cooling. The world is really getting hotter than before, and the heat waves are causing economic loss and human suffering. For example, this year, we have the hottest weather around the globe. I think if you are in Hong Kong, many of you can experience the heat waves in the summer. And there's a report in Wall Street Journal. And many people in Texas, they say they don't want to be there anymore because of the heat waves. Well, in Hong Kong, the urban areas are particularly more affected due to the urban heat island effect. In urban areas, lots of our lands are covered by pavements. For example, asphalt pavements or bituminous pavements. In summer, the pavement temperature can reach more than 70 degrees. So that's an important source of the heat island effect. Of course, another important cause is the blocked ventilation of the high-rise buildings. A study of 293 European cities found that land surface temperature observed for urban trees are on average 0 to 4 degrees lower in southern European regions and 8 to 12 degrees lower in Central Europe. So if the urban areas are covered by trees, the temperature will be greatly reduced, land surface temperature. Well, we also did a study using satellite data in Hong Kong and Singapore. We found out in Hong Kong, urban trees can cause a maximum temperature reduction of about 6 degrees and maximum average 3 degrees. In Singapore, the maximum temperature reduction is also about 6 degrees with an average of 2.84. Another benefit is water problem, is to solve water problem. Urban trees help manage stormwater. They can intercept a large quantity of rainfall and thus mitigate urban flooding. According to existing studies, a typical medium-sized tree can intercept more than 9,000 liters of rainfall per year. And here, these charts shows those pollutants in urban stormwater runoffs in Hong Kong. We collected a year of data from urban roads in Hong Kong and analyzed pollutants in urban runoffs. So these are different districts. Those roads, pollutants in the runoffs as compared to rainwater. So the pollutants in runoffs in stormwater in Hong Kong, they are several times higher than those in rainwater. In other words, they are heavily polluted. So here I show some microplastic photos. And the other two charts show phosphorus and nitrogen. Well, trees can significantly absorb or filter these pollutants in stormwater runoffs. Phosphorus, nitrogen are actually nutrients for trees. According to existing study, up to 95% of particulates and at least 7% 70% of heavy metal in urban stormwater runoffs can be filtered by tree box. And in recent years, we did some study related to nature-based solutions related to biodiversity conservation and biodiversity restoration. So here are two of our projects funded by Hong Kong government. One project, it's a Hong Kong and the European Commission collaborative project. The name is Development of a New Integrated Policy Payment and the Implementation of Urban Nature Labs. And another project is how to effectively implement nature-based solutions in urban development and urban renewal. So this project is funded by Chief Executive Policy Unit. We are trying to provide policy recommendation to see how we can integrate nature-based solution in urban development and urban renewal. So if you have some good advice, you could contact us and we will incorporate that in the policy paper. And regarding the European collaboration project, the full name of the project is called Urban Nature Labs. We have been collaborating with many European cities to see how we can solve many urban issues through nature-based solution. In other words, how we can use the power of nature to solve engineering problems or social problems. And before I move to the next topic, let me make a small advertisement. We are going to have a conference. It's called the title of the conference is 2024 Hong Kong International Conference on Nature-Based Solutions for Urban Infrastructure. The conference is co-organized by PolyU and the China Urban Forest Research Center under National Forestry and Grassland Administration and Technological and Higher Education Institute of Hong Kong. We are going to have many scholars and government officials from Hong Kong and many cities in Europe and mainland. And we are going to talk about the effective nature-based solutions for urban infrastructure. So this is the website, and that's the contact. So here next, I'm going to talk about some of the research we did related to this topic. The first one is river restoration. That's a part of the Urban Nature UNA project or Urban Nature Lab project. We collaborate with Europe. So in Hong Kong, in recent years, the government has initiated some river restoration projects. And as a part of our research, we try to assess or we try to evaluate the effects or effectiveness of these projects. So here are some common river restoration techniques. You know, most of these river, like in Hong Kong, these are currently used for drainage channels. So we are trying to see if we can revitalize these rivers to enhance their biological value and even provide some social services. So here are some commonly used ecological enhancement elements, like replace original concrete with eco-friendly substrates, create pools and riffles, fish ladders, etc. They also implemented some hard engineering features like palm fiber, concrete block, current deflector, etc. So in our study, we try to evaluate some of the river restoration. In Hong Kong, it's also called river revitalization. Some of these cases, we evaluate both suburban rivers, like the top one is called the Ma Wo River, and the Lantern River, and Kai Tak River. Kai Tak River is a more urban river. So here are some photos we took after the restoration project. Then the channel before restoration. So we evaluated the restoration projects from different aspects. One aspect is water quality. It's about water. And we also look at the hydromorphology, but due to time limit, I'm not going to talk about the hydromorphology. I'm going to just talk about water quality. We did a test. We did a water quality test from the physical chemical perspective, and we tested the solid content, aggregate organic constituents like a BOD, and the nutrients, indicator bacteria like E. coli and trace metals. So we did the on-site sampling and the test, and also we took a water sample to the lab and did the test. And in addition to this chemical test or physical chemical test, we also did some interesting test, water quality test based on biological indicators. They are commonly used to evaluate water quality. There are actually advantages of using biological indicators. Here are three groups of tiny water bugs. They are called EPT, three group. Okay, the first group, there's a long English name, but we can call them E. Okay, these water bug. We took these photos. Another group is P. Another group is T. Well, these water bugs, they are actually very good. They only live in clean water. Okay, if the water quality is bad, they cannot survive. So they provide biological indicators of water quality. As compared to these tests, there are actually advantages of using biological indicators to evaluate water quality, because these biological indicators give us a cumulative water quality indicator. Because when we take a water sample, we can only sample the water at a certain time point. We cannot test the water quality or monitor water quality all the time. These water bugs, they are exposed to a water environment continuously. So they give us cumulative water quality indication. So by evaluating the species richness and the abundance and the number of the species and the population under different species, we can clearly see or evaluate the quality of water. So we did the evaluation using these water bugs, and that's water quality. We also did a biodiversity assessment. So we evaluated the species richness, species abundance, and the species evenness of different species. For example, birds and dragonflies and fish. So we evaluated the speed of this biodiversity at a different location of a river in Hong Kong, ranging from the natural river in the upstream to the restored river to the concrete channels. So we used some quantitative indicators to evaluate the biodiversity. For example, the alpha diversity. One is called the Shannon-Weiner Index and the Simpson's Index. And those are for biodiversity assessment. We also try to evaluate the social impact of the river restoration project. So we did questionnaire surveys and individual surveys. We interviewed 295 people at the river restoration sites and asked them very detailed questions. So these are the case sites: Katak River, Mawa River, and the Lanchun River. And another area we evaluated was the resilience of this restoration project, because these restoration projects, they are located in the drainage channel. They are very heavily affected by flooding. So we try to see how the robustness or resilience of these projects in flooding. So this is how we evaluate the resilience of the project at 3 levels: engineering resilience, system resilience, and complex adaptive system resilience. And here we even developed a framework to systematically evaluate the resilience of this project. So here are some results. Firstly, if we compare the restored site with non-restored site, if we do the comparison side by side at the same time, we see some interesting pattern. So this is water quality. Okay, and in general, if we look at Mawa River, okay, it's a small river in North District, we can see a general water quality increase. If we look at another river, Lanchun River, we actually see a general water quality degradation. We believe the reason is due to different restoration technique. For example, at Mawa River, they use some lots of features like waterfall, fish ladder, and high salinity and vegetated pump. So this likely increases the dissolved oxygen level in water, and the dissolved oxygen level is highly related to overall water quality. Well, at Lanchun River, there's a pool, the engineering design, there's a pool. So this pool causes slow water flow and pollutant deposition. So that's likely cause degradation of water quality. And we also compared the restored river, the water quality of restored river to natural river at the upper stream. And we can see LT1 means restored river section, LT1, Lanchun River, in dry season and wet season. LT2 is upstream. And we can see the restored river quality generally not as good for this restored river section, not as good as the upper stream. However, if we look at the Tongtong River, TC means Tongtong River, TC1 means the restored river section, TC2 is the natural river at the upstream. At both sections, the river quality, the water quality, very good. However, these are physical chemical water quality property. If we look at the water bugs, those EPT, 3 groups of water bugs. So we found there are lots of these water bugs at the upper stream, but we can seldom find them in the lower stream. So these bugs which means if we use the natural river as a benchmark, so our restoration project still cannot reach high water quality. So regarding biodiversity assessment, of course, if we compare our restored river section with a concrete channel, we can see big improvement. So the right-hand side shows some charts, abundance and Shannon-Warner index. And if we look at the biodiversity, the abundance of different species of birds, fish, dragonflies, butterflies, and plants. So if we only look at the concrete channel, we can hardly find anything. Well, if we compare like the restored section, they are much better. Okay, and also if we use the biodiversity index, the restored part is also much better. However, if we compare our restored sites with the natural sites at the upper strip, it would be a different story. At the restored sites, we can indeed find some birds, interesting birds, lots of fish, and dragonflies. If we look at the natural sites, we can, if we only look at these different birds or fish, we don't see many. However, lots of these fish, they are protected species or rare species. And here shows we use a special curve. It's called the rarefaction curve. This shows the species richness, like different types of species, and the number of the individuals and their different species at a different site. Okay. LT means Lanchun, TC means Tongchong. Okay, it's different sites. Let's look at the bird, C. Now, if we look at the bird, LT1, the restored site at Lanchun, we can see there are lots of birds. Okay, and in both species richness and species abundance. It apparently, well, the river restoration is very good. And however, if we look at other species, okay, like fish, we see lots of these fish at Lanchun River. They are exotic fish. In other words, non-native fish. And they are very tolerant to those pollutants in water. If we look at the upper river, there are these protected fish, and we even have a very protected species in Hong Kong. It's called Hong Kong warty newt. So this species is unique in Hong Kong. Previously, people believe they only live in Hong Kong. In recent years, they also found some of these in Shenzhen, but generally they are quite local species. They are very sensitive to water quality. We cannot see any in the lower reach. So, in summary, okay, the types of animal and plants, even the plants in the upper reach and the lower reach are totally different. They're totally two different pictures. And regarding social impact, we actually have a very lengthy study on social impact. Due to time limit, I'm not going to introduce all the results. So I just provide some very basic finding, okay, a summary of the finding. Now, if we look at on the left-hand side, we show the respondents' emotional state when visiting the restored sites. KTR means Kai Tak River. So that's the restored river in the urban area. And the Mao River, Lanchun River, they are restored river in the relatively rural area. So this is the percentage of respondents, and the blue color means feeling happy. And as a slashed bluish color, another one is they don't worry a lot when they visit the sites. And another light blue means reducing anxiety. They feel their anxiety level is reduced when they visit the site. These are good feeling. We call them good feeling when they visit the sites. Another group, they are bad feelings. For example, they feel annoyed, feel angry, or depressed. They are not high quality feelings. So if we look at this chart, we can see, sadly, people at the KTR site, generally they are not as happy as those people at MWR or LTR sites. Okay, and we also try to find out, like when we do the river restoration planning and design as engineers, when we plan or design, there's a river restoration sites. How do regular residents think about them? What do they care about? So for the regular residents, okay, ordinary residents, and we try to understand their perception from five aspects. One is the disturbance of construction activities and cost, wildlife habitat, and landscape, recreational opportunities. So the blue one shows those residents at the KTR, Kaltak River site, what they think. The greens people, the respondents at the MWR, Mawa River, and the Lanzhou River. So we can see at the KTR site, people care a lot about the disturbance due to construction, like construction noise and impact, transportation, things like that. And another thing, they care a lot about recreational opportunities offered by the restoration sites. In other words, they hope after the restoration, they can use that as a park, for example. People can use the facility for recreational purpose. Well, for people at the other sites, like MWR and LTR, so their number one concern is wildlife habitat. So people there, they concern more about biodiversity. If that place can provide some habitat for wildlife. And another things are landscape improvement, recreational opportunities, and cost. Okay, and they don't care too much about construction. So this actually, we believe, make a lot of sense, because those are kind of like a rural site. Okay, those sites are a little bit far away to the residential area. So people are more tolerant to the construction activity. But in an urban site, in doing this type of projects, we really need to think about the disturbance caused by construction. Okay. Overall, both the rural sites and the urban sites, people like to use the sites after revitalization, use them as to have some recreational opportunities. And also, we have some interesting finding, like people's emotional state, how they are related to the site condition. We found out like our emotional state, like if we feel happy, positive, compared to those negative feelings, the higher the score, the better emotional state. We find that they are statistically significantly affected by biodiversity, like species richness. So if people go to the site, they see different plants, different birds, different dragonfly, butterfly. Generally, they have a happier feeling. And the second significant factor is the visual attractiveness. So if the landscape, they think it's beautiful, and air freshness. And another very important thing is auditory environment, means the sound. So if people can hear some nature sound, like the sound of water, sound of birds, sound of insects, they generally have some positive feelings. Well, if they don't have this, they generally have negative feelings. Of course, these are statistically correlation. Okay, this may not imply some causal effect, but they are statistically significantly related. Okay, I recently visited Fuzhou in Fujian province. So as surprisingly, I found out they try to incorporate these, not our finding because they did not read our paper. They incorporated these concepts in urban development. For example, okay, I was quite surprised when I visited them. I found out they try to build some nature corner, called corner of nature. So they try to create an area that's very close to nature. Okay, and they try to protect the area from noise because we experience lots of noise in city. So they want to protect some, we want to build some quiet corner. So in the corner, they try to introduce some nature sound, like sound of water, sound of birds, sound of insects. So they believe, okay, that will generally make people happy. So our research, the finding, the study we did in Hong Kong somehow coincide with what they are doing. That's the table show on the left-hand side. On the right-hand side, that shows a summary, like people in Hong Kong, according to our interview, what they want from the river restoration. So we can see they want to have some jogging trail, walkways along the river, bike lanes, playgrounds, etc. In other words, we as engineer, when we do river revitalization, in my opinion, we really need to think about the social impacts, how we can make the river restoration project or revitalization project serve multiple purposes. Okay, another area we try to evaluate was resilience. We found out, unfortunately, we found out many of those restored features were destroyed after a hurricane. So those are some photos we took after Typhoon Mangkhok in 2018. We continuously took some photos. We went to the site and look at the site. We found out, unfortunately, many of the features were damaged or destroyed. So we believe this engineering design problem. Many of the participants here, we are engineers. We can, in my opinion, our engineering design can be improved. Okay, and it indeed, we need to develop new design features. We have some ideas in our mind, and well, if you want to collaborate with us somehow, we could work together to improve the resilience of the restoration projects. So here above, those are some research we did under the river restoration. We did not participate river restoration design or construction. We did some post-restoration evaluation, but I think the lessons learned or experience are very important for future restoration projects. River restoration in Hong Kong offer many opportunities. We also did some conceptual study on eco-friendly corridors. When I worked in the US, we collaborated with the highways department over there, look at how to facilitate animal crossings on highways. And these are some photos I got from the internet. So these corridors, they try to build a corridor or underground culvert to facilitate animal crossing of the highways. In Hong Kong, we have some experience, but these facilities are not extensively used. So for example, I will use an example here, the conceptual example. So this footbridge in Hong Kong. In Hong Kong, we have 40% of the areas are protected. Compared to many other cities, they're very unique. The society as a whole is really care about biodiversity conservation. However, many of these protected areas are segmented. Okay, they are divided by lot. They are not connected. So from a biodiversity conservation perspective, we want these protected areas to be connected. Many studies have found that if we separate these different areas, the biodiversity value of the protected areas will be significantly dropped. Animals, they cannot move from one area to another. Okay, so as engineers, we design many engineering facilities to facilitate people movement, to facilitate the connection of people. So we also need to think about how we design these facilities to facilitate movement of animals. Okay, so for example, okay, so we did some modeling studies on the footbridge. We could easily retrofit the existing footbridge to green footbridge to facilitate animal crossings. So we did some hypothetical studies. We could, for example, we could have different plants on the footbridge that will not heavily affect the loading. But these green strips will greatly help those lots of animals to move from one protected area or green belt to another protected areas. For example, okay, at the beginning, I talk about those pollinators, like bees. Some bees, they are very capable. They can sense the flower. Okay, they can move from. They can sense the flower from a very far away place, so they can fly over the highway. Well, some other bee species, okay, some other bees, they cannot do this. Instead, they have to leave some mark on their route to the flower source. It's like if you have experience, if you have a dog, like a pet, you know, some dog, they like to urinate at some place, leave a mark. So these bee species, they also leave some mark. So after they fly a while, they leave some mark, and the other bees, they can sense this mark. biomarker, so they can fly those routes. So if we build this highway, right, so they cannot, those species, they cannot leave any mark. So they cannot move from one place to another. So if we have this green corridor, so those bee species can easily leave marks. So we also test what's in the air in different places, like at the rural sites, at the roadside. We find out the smell is quite different. The chemicals in the air are quite different. So there's some wild animals, if they are used to the natural scents, they may not get used to the scents along the highways. So we use CFD. We try to do some hypothetical study, and if we have a different wind direction, if we plant some flowering plants on the footbridge, how the scent and pollen will distribute in the air, and how that will will cover these different animal species and help them cross the road. In other words, I think there are lots of potential we can do, and lots of things we can do as engineers to help animal cross the road. And it's not difficult. We just need to have this mindset when we perform engineering design. It does not add lots of cost either, and it helps greatly. So recently, we also trying to do some roadside trees in Hong Kong, and I can tell you, trees offer lots of benefits in Hong Kong. We did a study. We tried to evaluate people's comfort, thermal comfort. So we interviewed. We actually really interviewed. We have a long interview. We interviewed 337 pedestrians in Hong Kong. And if you look at the two charts, the y-axis shows their comfort level, how comfort they are when they walk on the street. The x-axis are two thermal indicators. One is called PET, another is called UTCI. So these thermal indicators, they are affected by air temperature, relative humidity, wind speed, and the mean radiant temperature. So they are well-established equation to calculate the two indicators based on the four climatic parameters. Okay, in our research, we contribute this by connecting these indicators to people's comfort level. We can see here in Hong Kong, they are very good linear relationship between this climatic indicator and people's thermal comfort. Okay, those photos show how we did the study. So then we also try to understand, okay, how these different environmental factors affect those climatic indicators like air temperature and the mean radiant temperature. So that's some research we did, and we surveyed 305 trees. We found out they are really good in Hong Kong. Now, for the side-by-side study, okay, even the tree shaded area and non-shaded area, even they are very close, we can see clear difference in air temperature. Okay, this is the chart on the left-hand side is the air temperature. You can see the air temperature difference. Usually, originally, I believe there's no difference because the site is very close. The tree, no tree. But surprisingly, there's clear difference in air temperature. If we look at the mean radiant temperature difference reduction, it's even more dramatic. So we can see, okay, that's the mean radiant temperature reduction between the tree shaded area and the non-shaded area. The maximum mean radiant temperature reduction can reach 37 degrees, okay? And different trees offer different value. Okay, these are related to tree species. So this actually gives us a very interesting question as engineer. So as engineer, we usually want to select some trees that's easy to grow, okay, will not fall in hurricanes, very stable. But if we want to improve the urban thermal environment, we would perhaps select some other tree species. So that is a value of biodiversity. So we are also doing study at PolyU, and the rooftop, we planted many banyan tree. So we use artificially polluted water to treat the tree and to see how this tree can filter out the pollutants in storm water runoffs in Hong Kong. So far, the results are quite positive. However, roadside trees are not always blessings. Okay, falling trees are a hazard in Hong Kong, not just in Hong Kong, in Florida. So about 10 to 35% of urban trees were lost in 10 hurricanes. Okay, so Florida, US, has the same problems. So in 2018, Typhoon Mongkok toppled 46,000 trees in Hong Kong. In 2016, Typhoon Meranti toppled 350,000 roadside trees in Xiamen, mainland China. So tree stability is a big problem. And another problem is root heaves. They are all over the place in Hong Kong if we observe closely, and also in other cities. And even in early 1990s, a survey in California, they found out they needed to spend $11 per tree to solve the conflict between the pavements and the trees. And also, because if we want these trees to be very good, if we want the trees to significantly reduce temperature, to filter out pollutants, okay, we need the tree to be healthy, okay, to be in a decent size. However, trees surrounded by pavements do not grow well. So we can see here, this photo taken in Germany. I think this is very revealing. These trees, they were planted at the same time. We can see the closer the tree to the center of the parking lot, the smaller it became. And those trees at the edge, they're very good. They behave, they grow well. And this tree, the right-hand photo I took, it was a photo I took in Hong Kong. So the left side tree, originally, it's very similar to the tree to the right. And after paving, it became really unhealthy. Okay, that's a problem if we want to have these trees in Hong Kong, even they are very good. So there are many challenges of growing roadside trees in compact cities. Here are some photos I took. Okay, in Hong Kong, in many places, we have a very small tree pits. In a natural environment, tree roots coverage area is typically 2 to 3 times of its canopy size. This is not possible in compact cities such as Hong Kong. The tree pits can be as narrow as 0.3 meter in length. As a result, the trees are not healthy, not stable. And moreover, in a natural environment, tree roots form strong symbiosis with mycorrhizal fungi. You know, in our human body, we have some bacteria that's very good to help us digest. Okay, similarly, so trees need those mycorrhizal fungi. The trees provide fungi with food. Fungi help trees get nutrients and water. In a forest, more than 90% of trees' feeding roots are colonized by these fungi. They can extend root absorbing area by up to 40 times. In fact, there are several papers published in well-known journals, for example, Nature. They found out nature trees, they are connected. So that's why the longest surviving tree is a group of trees, not a single tree. So these trees, they can learn each other with water and nutrients through this fungi network. And these fungi, they require oxygen. Okay, like the photo I took on the right, that's the soil under pavements in Hong Kong. Okay. We like to use a lot of concrete, lots of bitumen, so there are little oxygen under the pavement. So as a result, the fungi cannot survive. Because the fungi cannot survive, they cannot help trees. So that's another reason why there are lots of tree problems in Hong Kong. So here are some existing studies. So they have this unique system to help tree grow, avoid overcompaction. And we found out that there are quite a lot of study at Cornell University. They try to change the soil mix design under the walkway, use a special soil mix to avoid compaction by human traffic. So to bring lots of oxygen to the soil, we are trying to do a study to solve the conflicts between urban roadside trees and the pavements and harness the power of healthy roadside trees to address urban problems. Okay, for example, currently we are trying to develop new pavement structures to protect tree roots from compaction, to send lots of oxygen, water, and nutrients to the tree root area. So for example, we developed this equipment to evaluate the oxygen diffusion in pavement materials. I give you two examples here. In one pavement material in Hong Kong, so the oxygen cannot pass the material even after 500 hours. Okay, in another material, if we change the material design, so oxygen can totally pass in less than 15 hours. So in other words, we civil engineers can make lots of difference by simply change the material design. So here are some existing studies. We try to use the MIC method or prefabricated roads. So we believe using this structure, we can provide enough space for tree root to grow. Okay, and in a recent conference, our new structure has won several international awards. In a recent conference, I met Professor Cheng Wang, should be Cheng Wang, sorry, not Chen Wang. He's the chief scientist of the National Urban Forest Research Center. He will be our keynote speaker in the conference. So I quote his word. It's not just in Hong Kong. In many cities, tree pits are only this big for urban trees. So you can see his gesture, okay, his hand, just show. While many tree pits, this small. And it would be a breakthrough if you could let tree roots grow into pavements. So, you know, our engineer, we are civil engineer, we don't talk to these plant scientists. Well, plant scientists, they don't understand pavements. They don't understand civil engineer. So it would be really good, in my opinion. Two disciplines can work together. Okay, we can make the trees, plant, very healthy, and we can use the power of the trees to solve some problems that cannot be solved by engineering means. And in our research, we try to understand the roadside soil, the abiotic environment like oxygen, moisture, temperature, and the biotic environment. And we try to use the soil in natural forests as the benchmarks to see how we can improve roadside soils. I already mentioned before, we try to use these trees to help solve water problems. And we are trying to make urban roadside tree research lab in Hong Kong. I really hope we can build this lab so this land to be converted into a pavement tree research lab in Hong Kong. So if successful, we can build the entire system to evaluate, improve constructability. We can test tree stability in hurricanes. We can perform a loading water test. We can do wind test. We can do lots of interesting studies to use biodiversity to help us to solve civil engineering problems. I think this is very beneficial if we consider we are doing lots of new town development, such as North Metropolis. They are located in environmental sensitive areas. This would also offer lots of education opportunities for undergraduate and graduate students. So recently we planted many trees on the rooftop at PolyU. We found out many students, they never planted trees, okay, never. And they were quite excited to have the opportunity to grow trees. So this provides some interesting education opportunities for future civil engineers. I sincerely hope to get support from you. So we also did a study about a framework of biodiversity for engineers. We understand we are trained as engineers. We are not biologists. So as engineers, how we can quickly evaluate our project is good. Our project protects biodiversity better than others. So we developed a theoretical framework for civil engineers. Okay, this is for civil engineer, not for biologists. So we try to use language or methods understandable to civil engineers to evaluate the biodiversity of the site. We call it this urban green infrastructure. We really did a lot of study, okay, lots of research. We summarized them. So these are some existing species people use to evaluate the biodiversity of the site. We try to make it simple. We try to answer 3 questions that are that may be interested by civil engineers. They are what to measure, how to measure, and how to analyze. In other words, what do we want to measure at a site? Okay, a building site or construction site. So here are some different criteria. And the second question is how to measure those different species like birds, fish, insects, because we are not trained biologists. So how a civil engineer can measure those? And we are also trying to, another question we want to answer is how to analyze. So we collect the data from a site. So what? How can we know its biodiversity is good? So we try to develop the system to help civil engineer to analyze the eco-friendliness of the site. So that's 3 questions, okay? What to measure, how to measure, and how to analyze. So we also developed a table to help engineer to evaluate the site. These are different criteria, like indicators. These are different group of species, plant, bird, fish, bee, butterfly, ordinates like dragonflies. So here are some representative etc. Okay, we use the framework, the tools to evaluate green roofs in Hong Kong, green roofs near PolyU. For example, this is green roof A located at the campus of PolyU. So we can see there's not much, right? And another green roof, this located in Metropolis. So we can see the very, it's an intensive green roof. There are lots of big plants, big trees, and the shrub and grass. So we use the tool to evaluate green roof A, green roof B, the birds and the plants. And we can easily convert the biodiversity value of these sites to quantitative indicator, because we know as an engineer, we like number, right? We like quantitative indicators. So by using our framework, we can easily evaluate the site by using these quantitative indicators and provide quantitative values. So conclusion, thank you very much, guys, for staying with me. I think I perhaps exceeded the time. In conclusion, biodiversity is good. They provide lots of ecological services. It's not just the moral obligation to conserve biodiversity. It's not just we try to do some good. We try to be good to protect biodiversity. It's more about ourselves, okay? Because biodiversity provides lots of services. As a human being, we take lots of valuable services for granted. For example, clean air, clean water. We think it's just there. It's not just there. Okay, we as a civil engineer, we do many things to provide people with a clean air and good environment, clean water. The ecosystem, they can provide lots of services. We should not take this as granted. We should protect them and utilize their services. So in Hong Kong has produced biodiversity strategy and action plan. Hong Kong is a very small place. The total area is only about 0.01% of China, the land area, but it hosts more than 3,300 species of vascular plants, including 2,100 native species, 57 species of terrestrial mammals, 540 species of birds, etc. About a third of bird species in China can be found in Hong Kong. So we should protect this rich biodiversity. And again, that's the last page. If you are interested in nature-based solution, if you are interested in biodiversity, you're interested how to connect biodiversity with our civil engineering practice, please join us in this conference. Here I show the website and the email. Please take out your phone, take a photo, and contact us. We welcome your questions, suggestions, comments, and critics, because our study area is not traditionally researched as a civil engineer. So I believe this will invite lots of questions, even critics. But please, okay, if you have any question, please ask. Thank you very much. Also thank HKIE Civil Engineering Division for providing me with this opportunity to share our research and our thoughts. Thank you. Now we can go to the Q&A session.
Thank you, Professor Wang. We will now proceed to the Q&A section. Please feel free to leave a message to the chat room if you have any question regarding the webinar.
You could also write to us, okay, if you do not want to ask a question here.
If there's no questions, I think we're going to end today's webinar. Thank you, Professor Wang. As the speaker of today, we have prepared carbon credit certificates for you as a token of thanks.
Thank
I'm
you,
sure
Fiona.
all of us have learned a lot tonight, and I hope you have enjoyed the webinar. The digital attendance certificates will be sent to you by email in 4 weeks. Once again, thank you very much for joining today's webinar, and we wish you all a good evening. See you all again in future events. Goodbye.
Thank you all. Bye-bye.